Okay, so we're here with chapter 3 of our night book. We're going to do problem number 45, which is a vector problem. And it reads, for the three vectors shown in figure 3.45, the vector sum D is equal to A plus B plus C, which has components D sub x is equal to 2 and D sub y is equal to 0. In part A, they would like to know what are the x and y components of vector B, and for part B, they would like us to find out what is the magnitude and direction of vector B. So you can see I've drawn a little sketch of the problem itself, what they've given us. I've kind of rearranged a little bit, and I've written down the given information. And the last little bit that they've told us, again, is that D is equal to A plus B plus C, those three vectors. So what we want to do is we're going to start part A by just looking at the vectors themselves. I'm sorry, not the vectors, the components. So we're going to look at just the x's and then just the y's. Because remember that the resultant, this resultant, they're calling it D, is the sum of the components of A, B, and C together. So we can say then that D sub x is equal to A sub x plus B sub x plus C sub x. And looking at what we know that D sub x is equal to 2, and A, because it's all along the x-axis, has a full component of 4. Right? B sub x has some sort of component that we don't know. Right? That's what we're looking for. And C is all in the y direction, so it has a horizontal component of 0. So just very quickly solving for this, we find that B sub x has a component of -2. Doing the same here for the y side, we get A sub y plus B sub y plus C sub y. And we know that then D sub y has a component of 0. A sub y has a component of 0 because, again, it's all horizontal. We need to find B sub y, and C sub y has a component of -2. Okay, and when solving for B sub y, we find that it has a component of 2 in the y direction. So these would be our two answers here, the two components that we're looking for in part A. For part B now, they're asking us to resolve these two components so that we can find out what exactly is B itself up here. All right, so if we look at it, it has an x component like this and a y component that goes like that. So to find that, it's pretty simple. We know that these two components make a right triangle. So B is going to be equal to -2 squared plus 2 squared and the square root of all that, right? Because it's just the Pythagorean theorem. And when we do that, we find that B is going to be equal to 2.83. Right? And when that's the magnitude, they also need the direction. So to find the direction, we learned in class that theta is going to be equal to the inverse tangent of y over x. So in this case, it's 2 divided by -2. Right? And we find that theta is equal to -45. Well, that -45 is this angle over here. Right? So if we're talking about measuring everything from the positive x-axis, so going from 0 and going over, we would find that this may be -45, but we can call it 135 degrees. Okay, so to sum it all up, vector B has a magnitude of 2.83, and it's in a direction of 135 degrees from the x-axis. All right, so there you go. That is problem number 45 from chapter 3.